All right, 1.6 is on classifying polygons. Today we're going to cover how you can describe and classify polygons in geometry. So a polygon is a closed plane figure with the following properties. It is formed by 3 or more line segments called sides, and each side intersects with exactly 2 sides. The sides are segments that form the polygon, and the vertex is an endpoint. This is where 2 of the sides will meet. So for example, everyone knows what a triangle is, I believe. So it's side, 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 and then these red dots, those each are a vertex. So this is a vertex. Right, the plural of vertex is vertices. So in a triangle, there are 3 vertices. A convex polygon is a polygon that has no dents. Okay, so convex will look like that. There's no dents in it. A concave polygon would be one that has dents. So for example, this would be concave. It's a concave polygon because there's a dent in the side. So this would be convex, convex, concave. An n-gon is a polygon with n sides. So for example, if it's got 23 sides, we'd call it a 23-gon. And there is a special name for every polygon, I think up to a pretty high number. But when we get above like 10, we just call it like a 15-sided polygon, we'll just call it 15-gon. All right, and you can go to the online book, or if you have a textbook checked out, on page 43, there are common names. You can also Google them. Like if you Google what's it called if a polygon has 18 sides, it'll show you a name. Equilateral is a polygon where all the sides are congruent. So it'll look like this. It would be like 4 sides. And actually I gotta fix that. That doesn't look good. Go like this. And all sides are marked congruent. So I'll use red actually. Those 4 red marks mean congruent. Equiangular is a polygon where all the angles are congruent. So for example, in this triangle, those blue arcs mean all those angles are congruent, so that'll be an equiangular triangle. And regular means that all the sides and all the angles are congruent. So for example, it will look like this. I know I didn't do a great job here. So if all the sides are congruent and all the angles are congruent, then it's called regular. So this polygon right here is called regular because all the angles are marked and all the sides are marked. All right, so in example 1, a polygon can be named by listing the vertices in consecutive order. So in this one, there's a few different names we can use for it. So if we start with B, when we go around the polygon, we could start with B and then C, D, E, A. Notice you have to go around the polygon. We can't jump around. We can't go B, D, A, C, A, E. That would not work. You have to go around the polygon. Another way would be like if you start with E, we could go E, A, B, C, D. That would work. E, A, B, C, D, That will be the polygon. That means the same thing, just you start with a different letter. So when naming a polygon, just pick a letter to start with and work your way around the polygon. So in example 2, tell whether the figure is a polygon and whether it is a convex or concave polygon. So the first one's actually no, and the reason why is because this line that goes through the middle. So that makes it not be a polygon, because in polygons, there's no vertex or segment that goes through the middle. And notice that at this blue point, there is 1, 2, 3 lines that intersect at that blue point. And to be a polygon, only 2 lines intersect at each vertex. The next one is yes, and this is convex, because there are no dents. And the last one is no, and this one is concave because of this dent right here. Okay, and then the checkpoint we'll run through them together quick. Tell whether the figure is a polygon and whether it's convex or concave. Number 1 is yes, it is. And are there dents? No, so we would call that one convex. And lastly, checkpoint 2, since there's a rounded edge, that's not a segment, so the answer is no, it's not a polygon, because polygons have segments, not rounded edges. Okay, example 3. Classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. So first, let's count the sides. There are 1, 2, 3, 4, 5, 6, 7, 8 sides. So if there are 8 sides, that would be an octagon. Or if you want to, you could call this an 8gon. But 8 sides should be a familiar enough number of sides that we can call an octagon. And then we gotta look. Is it equilateral, meaning are all the sides equal or congruent? So all these marks here mean that all the sides are congruent. And if you look, all these arcs that I'm gonna put in red, those red arcs mean all the angles are congruent. So it's equilateral and it's equiangular. That means that it's regular. Okay? And lastly, example 4, the head of a bolt is shaped like a regular hexagon. The expression shown represents side lengths of the hexagonal bolt, a bolt. Find the length of the side. So they tell us it's a regular hexagon. That means every side is congruent. So if this side is 5x minus 1 and the second side is 4x minus 3, we can set them equal to each other because we know it's regular. Regular means the sides are equal. And then we would solve this. I'm going to minus the 4x. And again, we got to cancel the 4x out because it's on opposite side of the 5x. So we get x minus 1 equals 3. Now we got to cancel out the minus 1, so you add 1. And you end up with x equals 4. So if x is 4, and we want to find the length of a side. So pick one of the sides, the 5x minus 1. And you have to put 4 in for x. So 5 times 4 minus 1 is 20 minus 1, which is 19 millimeters. And that's all we got for section 1.6.